Hi, welcome to Section 9 of the course. This is the second part of our coverage of deep learning. In the previous section, you learnt about the structure of neural networks, how a single neuron operates similarly to logistic regression. In order to solve challenging tasks more complex than those that are linearly separable, you have to have a network with at least one hidden layer. Indeed, you learnt that a network with a single hidden layer is as powerful as any network. Given enough neurons in the hidden layer, it can learn any mapping from input to output to solve a task. However, you also learned that deeper networks can learn mappings that are, in a sense, more efficient. They can learn mappings with less neurons and parameters. But as you've heard, no doubt, there is no free lunch. There is a price to pay. Deeper networks are harder to train. Engineers had to develop many new methods to be able to successfully train such networks. As an example, deep networks require lots of data and many thousands of parameters, or connection weights, to be able to learn the complex relationships between image and image content. This brings us to the topic of the current section. How can you set up and train a large-scale deep network? You need massive amounts of data. The data must be labelled. So already there are two issues: memory to hold the data and ways to collect massive amounts of labelled data. In this section you will learn how to use H2O for big data analysis. Call from R to make your code easily transportable, i.e. running on your computer to running in the cloud or cluster. In this section, in addition to H2O, you will also see how to use Keras and TensorFlow to write applications in R. Keras and TensorFlow efficiently run the code in parallel on multiple cores, or on GPUs if you have them on your machine. To use TensorFlow, you will need Python. We will link you to where to download Python and the additional libraries you will need. Lastly, this section will also give you the flavour of what deep networks can do, particularly with image analysis and consequent applications this technology enables. Things such as detecting and naming objects in images automatically. Technologies that underpin driverless cars to photo organisers and a great many applications yet to be invented by imaginative engineers and programmers. Perhaps you'll be the one to invent a whole new application. Be that as it may, I hope you will enjoy this section.